phosphodiester bonds, because you are now connecting 3' with the 5' of the next nucleotide base. Okay? So you have a one base and another base, right? So how that should be joined? From 3' hydroxyl group with the phosphate group of the 5' end. So if you are adding one after one nucleotide base in the 3' end, always the 3' end hydroxyl group will be free. And the 5' end, where there will be a phosphate group. Always at the 5' end there will be a phosphate group. Okay? So there will be two ends in a polynucleotide. One is 5', which is the left side, and one is hydroxyl on the right side. So in the text you will find DNA structure 5' arrow 3'. It's clear? Yeah. So if there's an arrow, meaning it is starting from the left, which is 5', there's a phosphate group, and on the right side there is a 3' end, which is hydroxyl group. And in between two nucleotides, there is a phosphodiester bond. And it's mentioned here polymerase chain reaction. So we are familiar with the polymerase chain reaction, right? Yes. No? Or yes? Yes. This is called PCR. This is a robust technology, right? So we can sequence the template of DNA using the machine, which is polymerase chain reaction. Now, how this DNAs in living system organized in the present? They form a double helix. So what is the proof? This is the double helix. What is the proof? Right? So scientists, they tried a long time during the 1940 to 1950. So they tried to find out, they knew that time the amount of A is equal to T, amount of G is equal to C. But they did not have any proof. So there is a double helix. So what is the double helix? Who postulated this? Watson and Crick. So Watson and Crick, they designed this model that DNA, the nucleotide, the polynucleotide, they present in a helical structure, double helical structure. So the one strand and the other strand, they are together, okay? And they are waiting for the years and years. There was no proof. So one lady, her name is, I think you know this, right? Rosalind Franklin. So Rosalind Franklin, first time in 1952, she's an X-ray crystallographer. She got this picture of image from the DNA. And Watson Crick, they took from her. Okay? It's like a stealing, right? And unfortunately, that lady died in 1958. And the Nobel Prize was announced in 1962. So she did not get the Nobel Prize. Although all the discovery is based on the only one X-ray film. Okay? This is the film, this is giving you three-dimensional structure of a DNA. How the DNA should be look like. Okay? And what does it tell? It tells you have a DNA, right? One template, and there's another one which is called antiparallel, or strand 1 and strand 2, which is opposite. And if you think about the ladder, so if you twist the ladder, so it will take a shape, right? It will twist, and it will form the double helix structure. And you notice I mentioned about here 5' and 3', right? Yeah. So this is the direction. The complementary strand, which is opposite strand. Okay? And this should be 3 prime, 5 prime to 3 prime, but in opposite direction. So always we write the DNA 5 prime to 3 prime, and another strand which is 3 prime to 5 prime. And if you look at here, the structure of a DNA. So this yellow, those are the phosphate groups. All the phosphate groups are outside, and all the bases are inside. Okay? So they are forming something special, right? And they are forming a bonding, which is hydrogen bonding. So why there is A to T? Why not A to G? Why not C to something else? Because of the number of hydrogen bonds. Because this number of hydrogen bonds, they can accommodate the best way. And I will show you in a minute that this is the structure. If you twisted the ladder, so it will take this shape. And this diameter, which is 20 Armstrong, any DNA, it is fixed 20. So if there is a change, so it will not be stable. So the A should go with the T, and C should go to the G. And if you twist the DNA, there are 2 strands. Okay? So one strand to complete the one turn, and there will be a gap between the one strand. There will be a gap, and this gap is known as major grooves. And there will be a gap between the 2 strands. Those are known as minor grooves. And when you go to the second year, so you'll know about the importance of those major grooves and minor grooves. And I have shown here the simple view of a DNA. So 5 prime to 3 prime, and again the complementary strand, which is 3 prime to 5 prime, A to T, G to C, C, G, G, C. So always the forming a hydrogen bond between A to T, C to G. So if I ask you in one of these template, or one of the nucleotide here, the one in the strand has 2A. So how many T should be in the other strand? 2T, right? So if my question is the total number of A, 4, how many T will be in this DNA? 4, right? So don't mix up 2, okay? One is the single strand, another is total DNA, is including the strand 1 and strand 2. Now, there is a bonding, because it's something, if I put together, so they cannot stay there, right? So there will be some force that keeps 2 strands together. So this is known as hydrogen bond, the bond between hydrogen and electronegative atoms, for example, oxygen or nitrogen. So in the case of adenine, A pairs with thymine, so there should be a 2 bond, right? 2 hydrogen bond. If you replace with something else, another base, they will not fit. So that's why they got the Nobel Prize. And adenine with thymine, there will be 2 hydrogen bond. In the case of CG, there should be 2 hydrogen bond. By the way, why is the nucleic acid? Where is the acid?
The middle.
Which one?
The middle.
The middle?
No, the other side.
Where?
The one between the bonding and the...
Okay. Why is called acid? Why is called acid? Very simple, right? Because of the phosphate, right? Because of the phosphate, this is acid. Okay? Now, I am showing here the hydrogen bond between. Okay, so you have the attendance, right? Let's finish the attendance.
لا من زمان أنا مش مقتنعة أحس الأب كده بعد ما يشتغل لو سويته 1000 مرة.
أنا اللي شفت
ترضيني
Done?
جالسين نحش حد
Done? Can I close it? So again, showing here the number of hydrogen bond between A and T and G and C. And this is the power to holding two strands of DNA together. And what is the difference between DNA and RNA? Huh? So the first difference is the base, right? So uracil present in RNA and thymine present only in the DNA. And another one is the sugar, ribose sugar or deoxyribose sugar. And number 3, they are structurally similar because they have T, U, A, C, G, right? Only replacing the one of the base. However, in the case of DNA, those are double helical structure. In the case of RNA, which is single stranded, only one strand. And if you look at the structure of DNA, it's like a ladder, double helical ladder. In the case of RNA, this is a folded structure. Although they can form a double helical if there is some complementary structure within the RNA molecule. So what is the function of RNAs? This is a nucleic acid, right? So bases are A, G, C, and EU, usually single-stranded, and there are three types of RNAs you can find in the living system. One, messenger RNA. So messenger RNA is the transcription process, right? DNA to RNA. This is the messenger RNA, and this messenger RNA carries the genetic information to make a protein. mRNA to directly to protein. Ribosomal RNA, those are present in the rough endoplasmic reticulum for the synthesis of RNA. For the synthesis of a protein. And transfer RNA, those are the carriers of amino acid. So those transfer RNA carries one after one amino acid to make a protein. Now, from this structure, the double helical structure, if I ask how many A present in this polynucleotides? 4. So you have to consider both. How many T? This is equal, right? And those are very simple things, right? How many G, how many C? And if I ask how many hydrogen bonds, so you have to calculate, right? Based on the CG, 382, right? So you can find out how many hydrogen bond in total in this double helical structure. I think this will be very simple. Okay, if I ask you how many hydrogen bond